In this video, we are going to learn how to find the domain of a function. First of all, we will learn what is the domain of a function. Let's start with a simple function f of x equal to 2x minus 6. Here, if you plug x equal to minus 3, then our f of x value is going to be minus 12. If you plug x equal to minus 2, then f of x equal to minus 10. And so on. If you plug x equal to plus 3, then f of x value should be 0. If you plug x equal to 4, then f of x value is going to be 2. And so on, we can do up to plus infinity. So here, x can be anything. It could range from minus infinity to plus infinity. Isn't it? The x value is input, the f of x values are output. Here x value you can take it from minus infinity to plus infinity. Now let's talk about the domain. The domain is the set of all input values, that means these all x values for which the function is defined and yield a real output. That is the domain. So here all these x from minus infinity to plus infinity, all these values the function is defined and yields a real output. So that's why for this linear equation, the domain is all real numbers. From minus infinity to plus infinity, all x values satisfied our given equation and yields a real output. So that's why whenever you have a linear function like this, your domain is all real numbers. That is minus infinity to plus infinity. If we have a linear function, the domain is real numbers. What about if we have a quartic function? Just like f of x equal to 2x square plus 6x minus 5. Here also the domain is same, all real values. The domain is all real values, that is minus infinity to plus infinity. Likewise, if we have a polynomial function such as 4x power 3 minus 3x power 2 plus f of x minus 3. Here also the domain is same, all real numbers. So therefore we can say that for linear function, quartic function and polynomial function, the domain is all real numbers. That's good. But what about for rational function and radical functions? Let's see now. Suppose if we have a rational function like f of x equal to 4 over x minus 2, how can you find the domain of this rational function? Let's see now. Here, if you plug x value as minus 2, then f of x is going to be minus 2 which gives minus 4 in the denominator. So then after cancelling, then you will get minus 1. So then f of x, the value is minus 1. If you plug x equal to 0, then our f of x is going to be 4 over 0 minus 2 which gives minus 2 only. So then 4 divided by minus 2 which gives minus 2. If you plug x value as 2, then f of x is going to be 4 over 2 minus 2 which gives 0. So 4 divided by 0 which is undefined. In this particular value, the function is undefined. Such numbers you should not take. So you have to take all x values that is going to be a function defined and yields a real output. So like that you have to take. But here when you plug x equal to 2, the f of x is going to be undefined. That means for the function, x could be anything except a value that's going to be produced 0 in the denominator. So whenever you have a rational function, you always set the denominator not equal to 0. If you add plus 2 on both sides, then you will get minus 2 plus 2 not equal to 0 plus 2. So then that is equal to x not equal to 2. We found that when you plug x equal to, the function is going to be undefined. But how can you represent this as a domain? For that, let's draw a number line. This could be anything except 2, isn't it? So a 2 should not take. Meaning all the left you have to take and all the right you have to take. That means your domain you have to write as all real numbers. Capital R represents as set of all real numbers except at single point 2, isn't it? This is your domain of this function. Let's see one more example for this rational function. Suppose if we have a function f of x equal to x power 2 plus 2x plus 1 over x raised to the power of 2 minus 8x plus 12. In previous example, we learned that whenever you have a rational function, you have to set the denominator not equal to 0. That's why. So, the denominator is x power 2 minus 8x plus 12 not equal to 0. Now, find the factors of this quadratic equation. The factors are x minus 6 not equal to 0, x minus 2 not equal to 0. That means x cannot be 6 and x cannot be 2. So that means at point 6 and 2 the function is going to be undefined. So that's when you have to take all the real numbers except these 2 and 6. So for that, how can you represent as a domain? You take all the real numbers minus except at 2 and 6. So this is your domain of this function. We can represent the domain in another way also. Suppose if you draw a number line minus infinity to plus infinity. So here we noticed x cannot be 2 and x cannot be 6, isn't it? So you should not take 2 and 6. Domain interval notation we can represent as, have to take minus infinity to at point 2. We are not taking at 2, we are taking in between this interval. We are taking only this interval minus infinity to 2. We are not taking exact this at 2 and 6. We are taking this between interval union 2 comma 6 union, again we are taking 6 to infinity. So this is interval notation for this function. Let's see one more example of this rational function. Suppose if we have a function f of x equal to 1 over x raised to the power of 2 plus 4. Whenever you have a rational function, you have to set the denominator as not equal to 0, isn't it? So that's why x power 2 plus 4 is not equal to 0. Since x power 2 cannot be negative, isn't it? Because if you take x as minus 1, if you do square, then it is going to be plus 1 only. If you take x as plus 1, then if you do x power 2, it is going to be plus 1 only. So it cannot be negative. Here, in this particular case, we should not take denominator as not equal to 0 because there is no real value of x that make the denominator 0. In our previous case, that is 1 over x minus 2 function, if you plug x as 2, then denominator is going to be 0, then it is going to be undefined. But in this case, if you plug all real values of x, the denominator is not going to be 0 here. So in this particular case, the domain is all real numbers. In this particular case, only the domain is all real numbers. So we can, another way we can represent this interval notation, that is minus infinity to plus infinity. This is the domain of this function. This is the special case. Let's go ahead. Radical functions. Radical is nothing but square root. And we have two types of square roots. One is even square roots, just like square root of x minus 2, fourth root of something 2x minus 6, and sixth root of, so these are the even radical functions. And if you have cube root of x minus 1, this is a odd radical function, isn't it? Suppose if we have x raised to the power of 2 over 3, it is nothing but x raised to the power of 2 whole power 1 over 3, isn't it? So this we can write it as cube root of x power 2. Raised to the power of 1 over 5, we can write this as x power 1 whole power 1 over 5. We can write this as fifth power x. So these are all odd radical functions. Now we are going to see how can how can you write the domain of these even radical functions and odd radical functions? First we will see the odd radical functions. Suppose if we have a function f of x equal to raised to the power of 1 over 5. We can write this as fifth root of x, isn't it? Suppose if you plug minus 1, then f of x is going to be minus 1 whole power 1 over 5. The value is minus 1. If you plug x equal to 0, then f of x is 0 power 1 over 5. The value should be 0 only. Suppose if you take positive 1, then f of x is going to be 1 whole power 1 over 5. The value is 1 only. If you take negative input, it yields real output. If you plug 0, it yields real output. If you plug x as positive, it yields real output. So that means all the negative values 0 and positive values, all values are defined here. So that's why for the odd radical functions, the domain is all real numbers. So for the odd radical functions, the domain is all real numbers. But what about the even radical functions? We will see that. Suppose if we have a function square root of x minus 2. If you plug x as a negative number, then f of x is going to be square root of minus 1 minus 2, which gives square root of minus 3. And we know that minus 3 we can represent as minus 1 times plus 3. So this minus 1 we can write it as iota square, which is nothing but minus 1. So instead of minus 1, I am going to write I power 2. So square root of I power 2 times 3, which gives root 3i. So which is imaginary. That means it is undefined. So for the negative values, the function is going to be undefined. That means for the even radical functions, negative values are not considered. So that's why whenever you have a radical function, that means even radical functions, you should take the function as greater than or equal to 0. Because negative values are going to be undefined here. If x minus 2 greater than or equal to 0, so if you add plus 2 on both sides here, then x is greater than or equal to 2. That means if you draw a number line, then x value is, so here x values are so equal to 2, greater than or equal to, that means you have to take 2 and you had and then 3 and 4 and so on up to infinity. That means you have to start from here and you go on take all these numbers. So whenever equal sign, you have to use closed bracket here. The domain should be closed bracket. That means at point 2 we are taking. So closed bracket 2, from 2 to plus infinity. These are the all possible values which are going to be defined in this function. This is the domain of this radical function. Let's consider another example. F of x equal to square root of x raised to the power of 2 minus 4. Just now we said that whenever you have an even radical function, the negative values are not going to be define the function. That's why you have to take this function as greater than or equal to 0. That means x raised to the power of 2 minus 4 is greater than or equal to 0. Then if write this 4 as 2 power 2, then it is in the form of a power 2 minus b power 2. So the formula is a plus b, that is x plus 2, a minus b, that is x minus 2, that is greater than or equal to 0. So that means x plus 2 greater than or equal to 0 and x minus 2 greater than or equal to 0. Here x greater than or equal to minus 2 and here x greater than or equal to plus 2. Here the function is x plus 2, x minus 2 greater than or equal to 0. So after draw the number line, here minus 2 and plus 2. So we divide into 3 regions, isn't it? This is the first region and this is the second region and this is the third region. For the first region, the values are minus infinity to minus 2. If you take any number in between these two, suppose if you take x as minus 3, then plug in this equation, that is x plus 2 means minus 3 plus 2, which gives minus 1 times minus 3 minus 2, which gives minus 5. So minus times minus, which use plus only. That means in the first region the function is going to be positive. If you take the second region, that means the second region the values are in between minus 2 and plus 2. Suppose if you plug x as 0 in this function, then 0 plus 2, which use plus 2, times 0 minus 2, which use minus 2. So plus times minus, which use minus only. The second region the function is negative. Now let's check the third region. The third region the numbers are plus 2 to plus infinity. Suppose if you plug x as 3, then the function is going to be 3 plus 2, which use plus 5, times 3 minus 2, which use plus 1. So plus 5 which is positive only, the function is going to be positive here. So for the radical signs, negative values are undefined, so we should not take this second region, we should take only the first and third region. That's why the domain is going to be minus infinity to minus 2 closed bracket, because equal sign, minus infinity to minus 2 union, and here also greater than or equal to 2, that means equal sign. That means you have to start at 2, then it goes up to infinity. This is the domain of this function. Let's see one more. Suppose if we have a function square root of x minus 2 over 3 minus x. How can you find the domain of this function? This function is a radical function and rational function. So in the previous example, I showed that whenever you have a rational function, the denominator you should take it as not equal to 0. The first point is you should take denominator as not equal to 0. And the second point, and this is a radical function. So always you have to take a radical function as greater than or equal to 0. So you have to take greater than or equal to 0. These are the two cases you are going to apply in this function. First take x minus 2 over 3 minus x greater than or equal to 0. Because of this radical function, we need to find the factors of this function. X minus 2 over 3 minus x. To find difficult this function, so in this particular case, what you have to do, you have to multiply divide by with the denominator. Here the denominator is 3 minus x is greater than or equal to 0. So then you get the factors of this function, isn't it? So here the factors are x minus 2, 3 minus x. This is the factors, and denominator we have 3 minus x whole square greater than or equal to 0. This is a rational function, that's why you have to take denominator is not equal to 0, isn't it? So from here we can say that x is greater than or equal to 2 and 3 is greater than or equal to x. That means x is less than or equal to 3, and from here in this case you can say that x cannot be 3. That's why you have to take x is not going to be 3, only x is less than 3. So these three conditions we have to define the domain. So from these three conditions we are going to find the domain of this function. Let's see how. For that, just draw the number line. So we have minus infinity to plus infinity, and what we have, x is equal to 2 and greater than or equal to. So if you take 2 here, so equal to, they are given equal sign, that means you have to use the closed bracket from here to all positive values, and then so our first condition is done, and then x cannot be 3. So let's take that. So x cannot be 3, you should not take this. And then the third condition is x less than 3. Less than 3 means from here to here you have to take only in between interval. So the domain is going to be close bracket 2, 3. So this is the domain of this function. I hope you like this content. If you like this content, please subscribe to my channel. Thank you for watching.